So today, as promised, we are going to talk about differentiating with trig functions. We are also going to add in the chain rule. So if you want to add that in to your objective, you absolutely should. The presentation is going to be number 12 from 3.5. You'll notice the homework split into two sections, one for trig and one for the chain rule. Now we're going to start with our trigonometric functions. Here I have a little table of each of the trig functions and its derivative. Now, hopefully, most of them you already know. The only ones that you have to have memorized, that you can't get away with not knowing, are sine and cosine. If you know sine and cosine and you've forgotten secant, for example, you could then say, oh, well, I want to know the derivative of secant. Well, that's the same as the derivative of 1 over cosine. And again, if you can remember cosine, you can then use the chain rule like we saw in the last lecture, or the quotient rule as we saw in the last lecture, to work out this fraction. But I do recommend that you do know all of them. It will just make your life a lot easier. So take this moment if you need to pause the video and make sure you have all of these written down or previously memorized. So in number 1, the position of a particle is given by the function s of t is equal to 5t cosine t. Find the velocity at t equals pi over 6. So now this is a really helpful time to talk about position velocity. So what you maybe remember from last year is that if you have a function f of x is equal to the position, then the first derivative is equal to its velocity at that time. So whatever position it is at x, its velocity would be f prime. Similarly related, the absolute value of f prime of x, or the absolute value of velocity, is called the speed. We will talk about second derivatives later on in this course, but if you remember the next one, the second derivative would be the acceleration. And though you never really come across the third derivative of these position functions in calculus, you might in physics, and that is called jerk. So when you see position and it asks about velocity, that just means that we're going to have to take its derivative. So here we're finding the derivative of 5t cosine t. And I will use the product rule. I'm going to separate it as 5t times cosine t as our two functions. The derivative of 5t is 5. The derivative of cosine is negative sine of t. So then s prime, which is the same as the velocity, would be 5 times cosine of t, these two together, plus 5t, that's an f, t times negative sine of t. So there's our velocity function, and then they're asking for it at pi over 6, so I'm just going to plug that in. So you'll notice here we've got our velocity of pi over 6, and just plugged in these values here. Now all you need to do is use your knowledge about sine and cosine of pi over 6. So you can use the unit circle if you like, which is how I am going to do it, to find the exact value without a calculator. Pi over 6 is going to be right here. So our cosine value is going to be root 3 over 2, and our sine value is going to be 1/2. And now we're just going to do a little bit of simplifying. And we get our velocity of 5 root 3 over 2 minus 5 pi over 12. You could keep combining those further, but I think that's just fine. So two things on this next slide. One is that there's another important trig limit that I'd love for you to have memorized. Of course, the first one was sine of x over x, which we saw with the squeeze theorem last week, and that's 1. Here is another one that's just helpful to know. Cosine of x minus 1 over x as x approaches 0, this is equal to 0. If you want to see a proof of that, it's in the PDF notes that are attached here. The next thing I want to look at is doing a little bit of practice with the chain rule. So I'm going to jump ahead for a second, remind us of the chain rule here, and that's if we have two composed functions is what this is called, where a function is plugged into another, then it's the derivative of the first times the derivative of the second. So another way to write that in this case is if we've got derivative of f of g like this, it's f prime of g times g prime. So in here we have a product rule and a chain rule going on here. For our product, I'll divide these like so. And here we have cosine of 3x. The derivative of cosine is negative sine, and the 3x just stays the same. And then for the chain rule, you then multiply that by the derivative inside those parentheses. The derivative of 3x is 3. Here, we have e to the 2x plus 5. We start with just e to the x, which is e to the exponent it has, and then multiply by the derivative of this fine function here, which I'll do out front, which is 2, since multiplication doesn't really matter the order. So here we have our two derivatives of our two original functions. So when I write f prime of x, I'm going to combine f prime and g. So in this case, 2e to the 2x plus 5 cosine of 3x plus g prime f of x. So negative sine of 3x times 3 times e to the 2x plus 5. If you wanted to simplify that a little bit, you absolutely could take plus a negative and just turn it into a subtraction. If you might factor these out. I picked up a weird place to put a parenthesis, but that's all right. We'll fix that. And so if you put it in factored form, which you don't have to, but just as a reminder, f prime in this case would be e to the 2x plus 5 parentheses times 2 cosine of 3x minus 3 sine of 3x. All right, we're also going to look at a table type problem like what we had before, where it's the same type of question, except for instead of h of x being f times g, it's f of g. So we're going to use the chain rule. Similarly as before, we're starting with our basic tangent line form. Y minus, in this case, h of 2 equals h prime at 2 times x minus 2 in point slope form. We're going to use the chain rule to expand that out. So here we have it expanded out using f and g. We're going to start with x equals 2. And we'll see g of 2 in both of these cases is plugged in. So we're going to start with that, and g of 2 is 3. And so now you can see that we're looking at g prime of 2 here, so we're going to stay in this column. But for f of 3 and f prime of 3, we're going to have to use this one here. So when we actually plug in our values, we get y minus 6 is equal to 2 times g prime of 2, which here is 5, times for x minus 2. So we're having to use both columns here as we plug in g of 2 to both of these functions. In its simplified form, we have y minus 6 equals 10 times x minus 2 in point slope form, or y equals 10x minus 14 in slope-intercept form. If you have questions about differentiating with trig or with our chain rule, please leave it in the comments or make an appointment in the calendar. I'll talk to you later. Bye.